Today, we'll do a history lesson into literal programming. Sometimes we have to go back and look at what was done in the past in order to understand what kind of solutions we can use today. So today, we'll look at literal programming paradigm, which was introduced in 1984 by Donald Knuth. We'll go through a hello world example and extract some key lessons relevant to making today's software more readable and maintainable. So first, what is literate programming? So literate programming is a paradigm in which computer program is written in a natural language, such as English. The programming language source code is embedded into the program's description. So the aim was to create an artifact that a human could easily take and read, much like a novel, without having to jump back and forth between different sections of different code files. The writer, the software developer, has complete control over the flow of the document, and this document can be reorganized in any fashion. So Knuth, who created literate programming, called his implementation web to emphasize that a computer program is built from many different pieces. So he picked this name before the World Wide Web was prominent. So to produce the source code, as we'll see, the user will run the tangle command to create the documentation. The user will run the weave command. Let's go ahead and jump into our example. So I'm not gonna type this out because I don't expect anyone to actually be actively using literate programming, or at least a very small percentage. So let's go ahead and take a look at a simple program that we wrote that just prints a hello world. So we will use a no web literate programming tool, which can be downloaded from GitHub or installed with Brew. It supports any language. It is language agnostic. All right, so let's start with this. So up top we have basic text, right? It's written in text. Literate program is written in text, and the comments, the descriptions are first-class citizen. For embedding the code, we will use these macros. So for example, the greater, greater, less, less, symbols, equal sign, ended by at, will be a macro, and this print macro can be used down below. So for example, down here, we insert this into another macro, and this macro is also used down here. So at the very bottom, we will actually create our full files. So we'll have a mypackage.go file that will contain my package, which I think is the package name, the imports, and the print, which we saw up here, the actual print function. Then we have similarly main go file and the go mod file. And that is the basic idea of literate programming. You write the text describing what the file does. It is pretty readable. You can easily read it from the top, and it's pretty, I wouldn't say completely entertaining, but easy to read. Something that you could just, open up and read just like a technical book. And then the code is snippets like this. All right, so let's go ahead and actually run this, compile and run this. So first we want to install it. So I already installed the no-web tool that I mentioned. The install command is brew install no-web. I already did that, so I'm not going to run it again. So let's go ahead and tangle meaning generate the source code. Unfortunately, there's no one way to generate all the files that we need. We need to generate all of them individually. So for example, I would go do no tangle -r go.mod. I'll specify my hello.mw, which is this file, and I will say the output will go to go.mod. And then to generate my package file, first I have to create a directory, my package, and then I'm gonna go ahead and I'm just gonna copy and paste for speed here. No tangle -r, my package.go, which corresponds to down here. this macro down here, and we'll throw it in my package.go, and then we'll do the same for our main.go file. So effectively, these three commands generated our three code artifacts. And we can take a look at them. Main.go, go.mod, my package. Not bad. So we can actually go ahead and run this, compile and run. Go run main.go. And it prints hello world and eventually exits. Sounds good. And to generate the documentation, we use the weave command. So no weave-html. We can create documentation in other formats, but let's do HTML, hello.nw, and we're gonna go make a hello.html file. There we go, we got our HTML file. Let's take a look at it in Firefox. So there we go. That's our HTML file. Nothing special really about this HTML file, right? Some a little formatting here, but nothing too crazy. Okay, so we showed how to create an example of a literal programming. So now let's talk about the key takeaways. So the key takeaway is that the software developer orders the code for maximum readability, as you've seen. So most of today's programming languages were not designed with readability as their top guiding principle. They often require the developer to put code in specific file sections or specific sections of a function, potentially distracting the reader who is trying to understand the code. So some examples include imports, right? You have to put your imports on top of the file. Functional and variable declarations. Sometimes your functional and variable declarations have to be in a specific spot in a function or in a class, or if you're using a nested function, it may need to be declared before it's used, things like that. Error handling code has to be often in a specific place. So today's IDEs, integrated development environments, have tried to help with this situation by automatically collapsing these boilerplate sections. And that has been a great help. However, we have not seen them take the next step of entirely hiding some of these boilerplate, or perhaps virtually relocating this distracting code. For example, moving the imports virtually from the top of the file to the bottom of the file. So this definitely is an area where today's programming languages and IDEs need to improve. Let's move on to our second lesson. So in literate programming, comments are first-class citizen. It is the natural language, the main body of the program. Source code, on the other hand, is delegated to macros in literate programming. So obviously comments are easy to write, and we can even enhance comments with some additional processing such as markdown, mermaid diagrams, etc. Now, many of today's language toolchains also have a preprocessor that generates HTML documentation from comments. However, as far as we know, none can mix arbitrary pieces of code with their documentation. Now, some companies have realized that their code could use some more documentation, so they have added linting requirements requiring files or classes or even functions to have some comments. However, developers are smart. They will do the least amount of work to get their job done. So this has led to some meaningless comments such as "this is a class," which actually make the code less readable. So the closest mainstream approaches today that we have to literate programming are computational notebooks such as Jupyter and various online tutorials. All right, they mix plain text with code, most often code that you can run. And these are great for like learning or sharing examples or even small programs, but generally they're not sufficient for the larger software projects. Another thing to mention is some IDEs support rendering comments in a different style than the rest of the code, including rendering diagrams. However, there is no standard that works across IDEs, and version version control hosting systems such as GitHub. Let's see what we want to mention. Comments, okay. All right, third lesson, third key takeaway from literate programming is that the code from multiple source files can be present in one place, can be present in this one, in our example, in this one hello.nw file. So literate programming allows us to include arbitrary source files in any one program file. This is helpful when you want to keep related code in one place, such as an interface and its implementation, or an abstract class and its implementation. Now that said, modern IDEs can find all implementation of an interface, and often they have a quick shortcut jumping between the interface and its implementation. Of course, developers can also write everything in one file and then have their own preprocessor that splits this file into modules or compiled units. Although this is a takeaway, I feel like it's not very critical, because oftentimes the developers of today have the opposite problem. The problem that today's developers typically have is they have a very large file that has that's no longer scalable. That's a big ball of mud that needs to be refactored into separate modules. So actually, the opposite problem is more common, where you have a big file that you want to make into smaller files. All right, now the last three are more kind of negative in nature as far as literate programming is concerned. So the fourth one is writing code is actually more difficult with literate programming. So let's go ahead and jump back to our code example. Can we do this? All right, there we go. So specifically, this layer introduces another level of abstraction and another set of tools that the software developer must be familiar with. Right? They need to be familiar with all the syntax and all these commands that we were running in our terminal. And this general lesson applies to any system that tries to kind of enhance the coding experience by adding another layer between the user and the code. So sometimes these systems have been successful, right? Higher level programming languages are one type of system, right, that abstracts the assembly code and adds another layer. However, in this case, the literate programming doesn't actually try to raise the level of abstraction. All it does is try to make the code more readable. So it seems like it has not provided enough value to the programmers to warrant adoption. So a new system needs to provide overwhelming benefits to switch to it. One recent example is TypeScript. TypeScript now is widely adopted, even though initially, at least, it was just a layer over the top of JavaScript. So number 5, these macros up here actually make the code more difficult to read and write. Right? The literate program contains macros with their own names, like print, message, my package, etc., adding to the namespace of names that are already present, my package. Oftentimes they're the same names, but nevertheless, and we have a function name here, things like that. So there's like more names to keep track of in a literate program. Let's jump back to the HTML. Let's jump back to HTML. So in HTML, as you can see, it also mentions the names, and the syntax is not even the same. The syntax is slightly different, right? Instead of 2 greater than equals, greater or equal signs, there's just 1. The thing is, this name up here doesn't provide any value at all, right? It shouldn't even be rendered in HTML. We should just have a link down here that we can, maybe it's rendered here, and here we have a link that jumps back up to here. But the reader doesn't actually need to know what this macro is called. Like, this is kind of exposing unnecessary detail to the reader. The other relevant point is that today, the general guidance is to make your variables and function names descriptive so the reader knows what they do without additional comments. This means that we can kind of effectively replicate some of the functionality of literate programming simply by refactoring our code. And this is one of the lessons. Refactoring is good. We can refactor our code into this function, which we effectively done, but this is just an example. And then, since we just have functions, typically you can put functions anywhere you want in a class or a file. So we can refactor those functions, give them descriptive names, and put them in basically a readable order for a maximum comprehension for the reader. Another thing to point out is perhaps this could have been rewritten. Let's see, this program teaches us how to, and instead of print, maybe we should just call it print to the screen, right? And we can kind of combine the two approaches here. Maybe something like this. We kind of combine the name of the macro with the comment. It's a little hacky, but I'm trying to make a point of the importance of descriptive variable names here. All right. And now the sixth key takeaway is that basically literate programming has very little to no tooling support. Since it's not widely used, it's missing syntax highlighting, IDE support, such as refactoring, things like that. It doesn't have a standard build system. As you've seen, I had to kind of generate each file individually. So the literate programming user must maintain their own custom build system. Another lesson, right, similar to the fact that adding another layer is more difficult, is that you also need good tooling support for widespread adoption. All right, that's it for today.